All right. So today we're going to be talking about some more accounting principles today, called permutations and something called combinations. So let's go ahead and see how this works. Last class we looked at how many different ways we can arrange some objects. Like, for example, how many ways could you arrange the letters A, B, C? Right? 6. So what would you guys get for that? 6, right? Because it's 3 times 2 times 1 because you're putting them in a particular order, right? Now, what if I asked you how many different ways you can arrange these? Well, let's pretend right now that blue A and the red A are different, right? It would still be 6, right? Yeah. And there's all 6 of the possibilities. You could have blue, red, and then the B. You could have blue, B, red, so on and so forth, right? But what are you noticing about how I set these up? But look at the horizontal pairs here. What are you noticing about this pair and this pair? Well, they're not the same because I made the colors different. But what if the colors weren't different? Then they would be the same, right? And so, gosh, how many possibilities if we ignore the color are there? There's 4, right? Yeah. So if we ignore the colors, actually there's 3. There's only 3, right? So how are we going to figure this out? Well, let's kind of backstep here a little bit. What 2 letters are the same up there? There's 2. How many repeats are there is my question. There's 2 repeats. There's by what I mean by 2 repeats is what in this set, how many repeats are there? There's 2. There's 1 and 2 A's. They're both A's, correct? So how many ways can you arrange those A's? You could have the blue in the front and then the red, or the red and the blue, all right? So basically, you look at how many ways you can arrange your repeats, and then you can divide that out of the problem, and that's what makes it become the result that we have. So let's go ahead and take a look at an example here. Go ahead and write down your directions. And number 1. Okay, guys, well, let's look at this word Bobby. We're trying to find out how many ways we can arrange them. First of all, we need to look at how many letters there are, right? There's 1, 2, 3, 4, 5. So 5 different choices I need to make. What comes first, second, third, fourth, and fifth? And how many options do I have for the first letter? 5 and 4, 3, 2, 1. But it's kind of deceptive, right? Because here's the problem. If I were to switch these 2 B's in the middle, would that really make a difference? No. So how many ways can you switch them? Now, we'll go ahead and we'll treat all the B's like they're the same. I know this one's a capital B, but we'll just treat them all like they're B's. So how many repeating letters are there in this word? There's 3. There's B, 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 right? Now, I need to take out all the different ways that those B's can be swapped with each other because they're all going to be the same thing anyway, right? So I'm going to divide out of it the number of ways that you can arrange those letters. So how many repeats are there?
3.
And how many ways can we arrange 3 things? 3 times 2 times 1. I'm going to divide out the number of ways that you can arrange those repeated letters because the arrangements don't have an effect on the outcome. The top makes it look like it does because it arranges everything, but we need to divide out those repeats. So in this case, we can just drop 3 divided by 3, right? 2 divided by 2 and 1 divided by 1. And what I'm really left with is what? 5 times 4, which is 20. All right, so 20 is the answer number 1. Let's go ahead and take a look at number 2. Now for you guys, these aren't American coins, but you know, let's go ahead and assume that they are. This one looks to me kind of like a quarter, so I'm going to say quarter. And this one we'll say is a penny. And we'll call these ones,
50 cents.
Sure, we'll call them dollars. That's fine. So if you guys don't want to draw the pictures, you can just write down the letters instead. So Same question, but there is a slight difference because we have more than one type of repeat in here. We have two types of repeats. So let's see what effect this has on our process. First of all, I need to find out how many ways I can arrange all these coins, right? So first of all, let's look at how many there are. There are a total of 6. So it's going to be 6 factorial, or the permutation of 6, where it goes 6, 5, 4, 3, 2, 1. There are that many ways to arrange those 6 items. However, I have 2 groups of repeats. I have a group of repeating pennies, and I've got a group of repeating dollars. So I need to divide out the total number of ways to arrange each of those groups. How many ways can you arrange two objects, 2 pennies here? 2 times 1, right? The first penny could be any one of the 2. The second one, there's only one option left. Let's take a look at the last one. I've got $3. So how many ways can we arrange $3? I have 3 options for the first, then 2, and then 1. And now let's go ahead and do our division before we do our multiplication. All right, well, the 3, 2, 1 will take out the 3, 2, 1 on the top. Now we have a 2 and 1 on the bottom, but that's okay, because the 2 can go into the 6, right? 3 times. Now 1, ignore it, because if you divide by 1, it doesn't do anything anyway, right? So what I'm left with then is 3 times 5 times 4, which is 60. And I didn't have to divide the 2 into the 6, right? I could have divided it into the 4. Just divide them wherever you can. Sometimes you might even divide that same number more than once. Like let's say I had another 3 down here. You just take that 3 out then, right? So just keep reducing it out. You should not have anything left in the denominator. Here are 2 problems for you guys to do. Okay, guys, the answer number 1 is 180, and the answer number 2 is 105.